The drum on that truck is never allowed to stop. Not in traffic, not at red lights, not ever. Because the moment it does, 8 tons of liquid stone starts turning into a solid mass worth $40,000 in losses. What you think is just a spinning barrel is actually a machine in a constant race against chemistry. Before we look at the truck, you need to understand what's actually inside it, because concrete is not what most people think it is. Concrete does not dry, it crystallizes. The moment cement powder makes contact with water, a chemical reaction called hydration starts. Calcium silicate molecules begin forming interlocking crystals that grow tighter and tighter until the whole thing is solid rock. You cannot pause this reaction. You cannot reverse it. Once it starts, the clock is running. At 20 degrees Celsius, you have roughly 90 minutes from the moment water touches cement to the moment the mix becomes unusable. On a hot summer day, that window shrinks to 45 or 60 minutes. This is the reason the drum cannot stop, and it is the reason why concrete mixer trucks are some of the most precisely engineered vehicles on any road. A concrete mixer truck does not just pick up a load and drive. It begins at a batching plant where ready-mix concrete is prepared under strict specifications. The aggregates, sand and gravel, go in first. These make up roughly 70% of the total volume. Cement is loaded from industrial silos, not bags. Water is added last, and the moment it is, ASTM C94 kicks in. This is the industry standard that governs how ready-mix concrete must be handled from that point forward. According to those specifications, the drum must complete its discharge before hitting 300 total revolutions. Not 301, 300. Every single rotation is tracked by a mechanical revolution counter bolted to the drum drive. The driver can see the count in real time. When that number gets close to 300, the concrete has to be poured, returned, or written off. The drum itself looks simple from the outside. It is not. It is a double cone shape, wider in the middle and narrower at both ends, mounted on the truck chassis at an angle of about 10 to 15 degrees. That angle is deliberate. It uses gravity to help control the mix inside. The interior of the drum is where the real engineering lives. 2 continuous spiral blades are welded along the inside walls in a helical pattern. This is essentially a large-scale Archimedes screw. When the drum rotates in the charging direction, these blades push the concrete inward and downward, keeping the heavy aggregates from separating. When the drum reverses direction, the spiral acts as a conveyor, lifting the mix and pushing it up toward the discharge opening. The drum walls are made from high-strength abrasion-resistant steel, typically 4 to 8 millimeters thick. The blades are even thicker and are often replaced every few years because concrete is essentially liquid sandpaper. It grinds everything it touches. The drum is not welded directly to the chassis frame. It sits on dampers and spring-loaded mounts that absorb the continuous vibration of driving on roads. Without those dampers, fatigue cracks would form in the steel within months. Rotating 20 tons of viscous concrete requires more power than the truck engine can deliver directly. The solution is a dedicated hydraulic drive. Motor does not connect directly to the drum. Between the motor and the drum is a massive planetary gearbox. The motor spins fast and generates relatively low torque. The gearbox converts that into extremely slow rotation with enormous turning force. That is how a motor the size of a suitcase can rotate a drum carrying the weight of 2 fully loaded SUVs. During transport, the drum agitates at about 1 to 2 revolutions per minute. This is enough to stop segregation without consuming unnecessary revolutions from the 300 count limit. If mixing is still needed, the drum speeds up to between 8 and 15 revolutions per minute. The hydraulic system generates significant heat under sustained operation. A separate oil cooler with a fan is mounted on the frame to prevent oil degradation, which would otherwise destroy seals and pumps within hours. Here is something most people never think about. When a fully loaded mixer climbs a steep grade, it looks like the concrete is about to pour straight out the back. It does not, and the reason is counterintuitive. It is not centrifugal force that keeps the mix inside. It is the geometry of those internal blades. When the driver increases drum RPM on an incline, the blades actively scoop the concrete and push it deeper into the drum, toward the closed end. The faster the rotation, the more aggressively the spiral pulls the load inward. The driver controls this from the cab, adjusting drum speed based on grade and load. If the drum stopped entirely on a 15-degree incline, the concrete would immediately begin running toward the discharge opening under gravity alone. A drum with a geometric volume of 12 to 14 cubic meters can only carry 8 to 10 cubic meters of concrete. This is not a limitation of the blades or the hydraulics. It is a structural and safety limit. Wet concrete weighs approximately 2.4 to 2.5 tons per cubic meter. A full 10 cubic meter load is 24 to 25 tons. Add the truck itself, the drum, the hydraulics, the water tank, and you are approaching the legal gross vehicle weight limit. Overloading does not just break road regulations. It shifts the center of gravity high enough that a single pothole in a sharp turn can tip the entire vehicle. This is why most mixers run on 4, 5, or 6 axles. More axles spread the load across more contact points, keeping each axle within legal weight limits and reducing stress on road surfaces. If you are finding this breakdown useful, subscribe. This channel covers exactly this kind of engineering that looks simple from the outside. Every concrete mixer carries its own water supply, typically 400 to 600 liters in a pressurized tank. This water has two uses. First, minor slump adjustment. If the concrete arrives slightly too stiff for the pour conditions, a precisely measured amount of water can be added. ASTM C94 allows this but strictly controls it. The water must be added before the 300 revolution limit, and the drum must turn at high speed afterward to fully distribute it. Adding too much water destroys the water to cement ratio, which directly determines the final strength of the cured concrete. Second, drum cleaning. After every delivery, the drum and chute are washed down before returning to the plant. If this step is skipped even once, residual concrete begins hardening on the blades overnight. By morning, the driver is chipping rock off steel by hand. When you see small concrete cylinders sitting next to a mixer truck on a job site, those are not waste. They are legal evidence. Standard cylinders, typically 150 millimeters in diameter and 300 millimeters tall, are cast from the same batch being poured. They cure on-site under real-world conditions and are later tested in a certified lab under a hydraulic press. The press slowly increases load until the cylinder fractures. The fracture pattern and the pressure at failure determine whether the batch met its specified compressive strength, usually measured at 28 days. A uniform cone-shaped fracture is a pass. A shear fracture along a single diagonal line can indicate problems in the mix proportions or curing conditions. These results are legally tied to the delivery ticket and kept on file. This is one of the least talked about components on a concrete mixer, and one of the most important. Every revolution of the drum is recorded from the moment mixing water is introduced at the plant. The counter is mechanical, bolted to the drive system, and visible to the driver. Once the drum crosses 300 revolutions, the concrete is considered potentially compromised. It may have lost workability, begun early strength development, or undergone excessive air loss. The driver cannot legally pour it. Depending on the situation, the load either goes back to the plant or is dumped. A full truck of concrete returned is roughly 1,000 to 2,000 euros in direct losses before you factor in the truck's time and fuel. If the hydraulic drive fails while the truck is sitting in traffic and the drum stops completely, the hydration reaction does not stop with it. In hot weather, the mix can begin setting in under 20 minutes of no movement. Once hardened, the concrete bonds directly to the spiral blades. Removing it requires either a worker climbing inside with a jackhammer, ultra-high pressure water jetting at up to 40,000 psi, or in severe cases, cutting the drum open with a torch. A replacement drum from a manufacturer like Liebherr or Putzmeister costs between 20,000 and 40,000 euros, not including labor, reinstallation, and recalibration of the hydraulic controls. A single traffic jam on the wrong day can end a truck's working life. The driver of a concrete mixer is not just driving. They are managing a chemical reaction in real time, with a 300 revolution countdown, a temperature-dependent window, and a load that turns from asset to liability the moment the drum goes silent.